Hi, welcome to Database Management System video lecturing. Myself, Ranganatha K, Assistant Professor, Department of Information Science and Engineering, Canara Engineering College, Mangaluru. In this video, we are discussing the following topics. First one, the database language and interfaces, database management system interfaces in that, and then third point is DBMS component model, and the fourth topic is basic client server architecture of DBMS. So first we will start with point 1, that is database languages and interfaces. There are different set of database languages we are using to create the database and to maintain the database, to retrieve the data, to delete the data, to modify the data. So that are all different languages we were using. So once the design of a database system is completed and a DBMS is chosen to implement the database, the first step is to specify conceptual and internal schema for the database. These are some of the database languages which we are using to implement the database, and as well as to specify the conceptual design and as well as internal for a database design. First one is data language, that is DDL stands for data definition language. Second one is storage definition language. Third one, view definition language. Fourth one, DML language. DML stands for data manipulation language. And the last one is transaction control language. Now we will start with one by one. So which are all the command prompts we were using so for the DDL, SDL, VDL, DML and TCL. Now you can see, so this is the figure. So this figure represents which are all the different set of commands we were using for the different DBMS languages. So first one, data definition language. The data definition language, it is used by the DBA and by database designers to define both schemas, and the DBMS will have a DDL compiler whose function is to process the DDL statements in order to identify the description of the schema constructs and to store the schema description in the DBMS catalog. Example for the data definition languages are, first one is create command, second one is drop command, third one is truncate command, and last one is rename command. So these are the different data definition languages which we are using to design our database. Basically there will be a DDL compiler. The DDL compiler will compile these commands which we are using to create the database. So create is one of the command which we are using to create the database. So in the to create the database. So while creating we are using this command, create command. Drop command we are using to drop the database from the database. So fully we are going to remove the database from the this command, that is drop command. And truncate command, the truncate command will going to remove the contents which we are selecting. And last one is rename command. The rename command, we can also change the table name or database name by using this rename command. We can update that given table name and as well as database name by using this command. Second set of database language is data manipulation language. The data manipulation language, so we were using, so these are all the commands under this database language command. First one is select command, second one is insert command, third one is delete command, next one is update command. So now basically, so first command is, it explains about the selection of the data from the database. When we want to select any content from the database, then we are using this data manipulation language. Once the database schema are compiled and the database is populated with the data, users must have some means to manipulate the data. So whenever user wants to do the modification for the existing data, he can do by using these are all the commands. One is whether he want to select the data from the database, he can select by using this command, select command. Insertion, when he want to update by inserting the value into the table, he can insert the value by using this command. And third one is, so if he want to delete a value from the table, then he can use this delete command, update command. So whenever he want to modify some data from the database, he can use update command. These are the some of the set of commands where we are using in data manipulation language. Next one is data control language. In short form, we can call it as DCL. Data control language, these type of commands we were using to control the transactions either in a revoke or grant manner. So these are the two commands which we are using to block the database, that is extraction of the database, or permission to insert or to modify or to delete or to create. There we are using grant or revoke command. Then next one is transaction control language. Under this transaction control language, here we are using once again rollback and commit commands. The commit command is nothing but to save the data into the database, we are using the commit command. So rollback is nothing but whenever we are doing transactions in the, so from the client to server, if any failure occurred whenever we are doing a transaction, then we need to roll back all the transactions which we have done during the client and server communication. So then one more is there view definition language. The view definition language is to specify user view and their mapping to the conceptual schema. But in most DBMS, the DDL is used to define both conceptual and external schema. And one more is stored definition language, SDL. The SDL language, it is used to specify the internal schema, and the mapping between the two schema may be specified in either one of these languages. Next is DBMS interfaces. There are several DBMS interfaces are there. To make a user-friendly interface along with the DBMS, we are using a different set of interfaces facility. The first one is menu-based interfaces for web client or browsing. Second one is form-based interfaces. Third one, graphical user interfaces. Fourth one, natural language interfaces. And fifth one is speech input and output interface. And sixth one is interface for the parametric user. And last one is interface for the DBA. The first one, menu-based interface for web clients or browsing. Here the menu will guide the user to build his own query based on the step-by-step sequence of request. However, he will be selecting that sequences based on the step-by-step procedure manner he will be building. So he will going to give the guidelines so for the users. This query will get executed and the result gets displayed on the terminal. There is no need for the end user to remember the commands. So like for example, creating an email account used in a browser interface. This is one best example how we are using menu based interfaces to interact with the database. Second one is form based interfaces. The form based interfaces are nothing but it is the next level of designing interface. Here each user is provided with a form and the entries are made by the user based on the request to be submitted. This form gets executed and the output gets displayed. The user are aware of how to use these forms and values that can be passed to these fields. For example, clerk in a bank knows how to initiate the action of debit and credit by using predefined forms. Next, third type of user interface is graphical user interface. A graphical user interface, in short form we can call it as GUI. A GUI typically will display a schema in a diagrammatic form, and the user will be allowed to select appropriate columns and can also choose appropriate conditions. The result will be based on the mapping of GUI selected on the database. This is how the graphical user will be interacting, or graphical user interface will be interacting with the DBMS. Next, fourth one is natural language interface. The interpretation of a query similar to the natural language, easy to understand and use. The main disadvantage is that the complex representation cannot be initiated under this natural language interfaces. The language can be used for a specific set of keywords only and has a predefined schemas. But this is also known as key based query. Natural language interface, we are also calling it as a key based query. Then fifth DBMS interface is speech input and output interface. Here, in the speech can be used as a mode of transfer the query into the DB. This interface, thereby a query will get executed by using this kind of interfaces. There will be a specific words are used for the construction of the query, and it's becoming common for most of the applications. For example, inquiry about a product over an automatic telephonic conversation. So we are giving a speech as an input. That speech will be executed or interfaced to the DBMS, and the DBMS will be responding for us. Then interface for parametric users, and as well as interface for the DBA users. This DBA and parametric users can use any set of interfaces which we have explained in above. Like they can also use through natural language interfaces, or graphical user interfaces, or form based interface, or menu based interfaces, or else they can also use the commands. By using command user ID and password, they can also interact directly with the database. This is about DBMS interfaces. This slide, the database system environment topic, we will going to cover. Under that one, DBMS component model. So this is the figure which will going to give a clear picture of the DBMS component model. So here we are having a DBA staff, casual users, application programmers, and parametric users. The total, this entire diagram is split into two sections. One is user of the DBA, and second one is DBMS execution components. This is a half part where DBMS execution component will be there. These are the different set of users. So now we will start with the first type of users are application programmers, and second one is parametric users are there, third one DBA staff will be there, and last one is casual users. First one, application programmers, who work with the interactive interface to formulate the queries, application programs, who create programs using some host programming language like C++, Java, .NET. They are using to create the application programs. Those application programs are pre-compiled by the compiler, where the pre-compiler will segregate the application program and as well as database query program. Then that pre-compiler will send the host language compiler will execute the main code, that is host language, then the DML compiler will compile the database languages, that is which is modified or which is wants to create whatever the request is coming from the application programmer, that part will be executed by the DML compiler. Then it will be transacted to the compile transaction. So then the information or instructions will be sending back to the runtime database processor for further processing. That is about the application programmer. Second one is parametric users. The parametric users are those who are using occasionally this data, who do the data entry work by supplying the parameter to predefined transactions. Whichever the predefined transactions are there, so for those transactions, so these are these users, they will going to supply the parameter for those transactions. Then third set of users are DBA staff. So the DBA staff is nothing but who works on defining the database and tuning it by making changes to its definition using the DDL and other privileged commands. So the DDL statements, data definition statements are there. The data definition statements are executed by the DDL compiler. So this DDL compiler will identify the DDL statements, and that statements will be executed, and that data definition structure will be there, that will going to store inside the system catalog, or we can also call it as data dictionary. Then privileged commands are there, that privileged commands will be transacted to the runtime database processor, then for further processing. Then last type of users are casual users. These casual users and persons who occasionally need for information from the database to interact using some form of interfaces, which we call the interactive query interfaces. Through this interactive query interface, the casual users are interfacing with the database. These queries are parsed and validated for correctness. So once the validation has been done for the syntax and the name of the file and all other information will be checked over here, and data elements and so on by the query compiler, and the compiler then compiles them into an internal form. Among other things, the query optimizer is concerned with the rearrangement and possible reordering of these operations, elimination of the redundancies, and use of correct algorithms and indexes during this execution. So this is about the half of the part of the database component model. Next half is, that is query and execution transactions. This query and execution transactions, so basically the point 1 will comes runtime database processor. This runtime database processor is a lower part of the database where it is executes the privileged commands, the executable query plans, and the canned transactions are undergoing under this runtime database processors. It works with the system catalog and may updated it with the statistics, and also it works with the storage data manager, which in turn use basic operating system services for carrying out low level input and output, that is we can also call it as read write operations between the disk and the main memory. The concurrency control, backup or recovery or subsystems are there. These systems are separately as a model. They are integrated into the working of the runtime database processor for purpose of transaction management. This is about the database component model diagram. The next topic is centralized client server architecture for DBMS. The centralized DBMS architecture will looks as shown in the figure. A physical centralized architecture will includes hardware, software and terminals. The terminals are nothing but display terminals like monitor. That monitors are connected through a network, and in the software there will be an application programming software, then terminal display controller will be there, and different set of text editors will also be existed in the software. And also along with that our DBMS software will also works, and next different set of compilers will also be existed in the software part. In the hardware part, the all the in between software and hardware there will be an operating system. The operating system will act as an interface between the hardware and software, and then in the hardware we are having a CPU, controller, memory and disk, and IO devices like printer, tape drivers. So that are all will be connected. These are all will be connected through a system bus. This is how the DBMS architecture will looks. Now we will talk about the basic client server architecture. The basic client server architecture will looks into two-way manner. One is logical and second one is physical manner. This is first example or first picture will be showing a logical two-tier client server architecture. Second one showing the physical two-tier client server architecture. How this client server architecture will looks in the DBMS. Now the DBMS software, so server will be there in a one system, that is DBMS server through network. So with all the clients are connected through network to this server. There will be a printer server and file server. So those are all will be interconnected with each other through a communication cable, that is internetwork. So through that they are communicating with each other. We are extracting the information, we are storing back the information into the database. Then physical two-tier client server architecture so will looks like, so for example here you can see this is the client 1 site, this is the client 2 site, there will be a server, there will be a number of clients. They are all interfacing or interacting with the one communication network. Through that communication network only they are interfacing together. This is how the client server architecture will looks. Okay, means there will be only one server and remaining all the in this architecture there will be only one server, n number of clients will be communicating through this server. Those are all the servers, either they may connected through a network. The communication network might be a wired network or wireless network. So by using that they can store the data into the database, that is server, and they can fetch the data from the database. This kind of architecture we are calling as client server architecture. Next, this client server architecture were developed to deal with the computing environments in which a large number of PCs or workstations, file servers, printers, database servers, web servers, email servers and other software and equipments are connected via internet. In this client server architecture, idea is to define a specialized server with a specific functionality, like a file server that maintains the files of the client machine, and also printer server to print so from this client to the server. And there will be a client and server relationship, and there web servers will be there. Through that email they can extract the information, they can store the information, so through this mail. Okay, so that is about a two-tier client server architecture. Now so this in the two-tier client server architecture, query server or a transaction server, so where we are executing the information on the server only, and server platform SQL server will helps to execute all the DBMS related query and to store the data into the database, to fetch the data from the database. So this kind of architecture will helps to share and to store the data into the database. The user interface programs and application programs we can also run on the client side, so that can also be done on the two-tier client server architecture. When DBMS wants to access, so DBMS access is required, the program will going to establish a connection to the DBMS by using which on the server side. Once the connection is created, the client program can communicate with the DBMS. a standard connection, we can call it as open database connectivity. In short form, we can call it as ODBC, which will going to provide an application programming interface. Through this interface, the data will be communicating between the client and server, which allows the client side programming to call the DBMS as long as the both client and as well as server machine have the necessary software needs to be installed. The server level may include the part of the DBMS software that is responsible for handling the data storage on the disk page. Local concurrency control and recovery, buffering and caching of data pages and other such functions will be done across the server level. In this client level, we're going to handle user interface and data dictionary functions will be done in the client level, and DBMS interactions with the DBMS programming language compilers will be using, and global query optimization, concurrency control and recovery across the multiple servers will be done at the client level machine, and also structuring of complex objects from the data in the buffers and other such functions will be maintained under the client level programming. And the architecture will be described here are called two-tier because the software components are distributed over two systems. One is in the client system and second one is in the server system. The next DBMS architecture is three-tier architecture and also entire architecture. For web application purpose, we are using these kind of architectures. The three-tier architecture is an intermediate layer was included between the client and as well as server. This intermediate layer also referred as application server, or we can also call it as web server. The intermediate layer, it is used for the logical execution or business rules. The process of execution would be the client gets connected with the intermediate layer, and that intermediate layer would get connected with the server using the ODBC connections, that is through API, that is application interface, that is application programming interface through that. So server and as well as clients will be communicating with each other. The server contains the only database and the user interacts with the client system here, and as well as the user request will be accepted by the client interface, and that request for the connectivity will going to initiate, that initiated once the connection will be established. The query is passed on to the intermediate layer, that is application program layer or business logic layer. Then this intermediate layer will going to check the logical syntax and as well as conditions before passing it on to the server. The output of execution is passed back to the client. There can be a multiple layers which we can define between the client and server for reducing the complexity of the execution. This is referred as entire architecture, where n may be 4 or 5 based on the application, based on the requirements. This intermediate layer can be enhanced, can be extended based on your business logic layers. This is about your three-tier architecture and entire architecture for your web applications. Next topic is classification of database management system. Several criteria are normally used to classify a database management system. So those criteria, basically 4 criteria are there. Based on that criteria, so we have made a classification of the DBMS. The first criteria is based on the data model, second criteria is based on the number of users, third criteria is number of sites, and the last criteria is based on the cost. So we have classified a DBMS system. The first criteria is the data model on which the DBMS is based. That is nothing but under this data model. So we were having a relational data model. That relational data model is used for in many commercial application purpose or many commercial system purpose also. Object data model, and hierarchical data model and a network data model. These are all the data models will comes under the first category or first criteria. So where we have classified our database based on these models. Second set of criteria, so we have classified our DBMS is based on the number of users. So there are basically two types of users are there. One is single user and second one is multi-user. The single user is nothing but so where it supports only one user and are mostly used with the PCs. And second set of users are multi-users, where which system will supports in most of the DBMS software, like how we are doing a client and server connectivity manner. Their multi-user transactions or multi-user communications will be undergoing under this second criteria. And the third criteria, so is the based on the number of sites over which the database is distributed. So the database is distributed is a centralized manner. If the data is stored at a single computer site, then we will call it as a centralized manner. And second set of number of sites is nothing but distributed DBMS. In short form, we can call it as DDBMS. Okay, it can have the actual database and the DBMS distributed over many locations under this distributed as compared to your centralized one, because server has been distributed, the data is also distributed with many locations. And third, number of sites where based on the number of criteria of number of sites, so the database is classified, that is heterogeneous DBMS. Heterogeneous DBMS is nothing but it supports to access several databases. That's what we were calling it as it is a heterogeneous DBMS. These are the some of the classification of the database management system based on several criteria. And the last criteria is, that is fourth criteria, based on the cost also we can classify our database management system.